Okay, rather unusual problem, but what I'm going to do is I'm going to take this thing and just simplify it. It's really not that bad to simplify. And what do you get? You're going to get a squared x squared plus b squared y squared plus c squared z squared plus 2. And then you're going to get, well, it's going to be a tough one. So it's abxy. And then it's going to be AC, XZ, and then it's going to be BC, YZ. Kind of nasty, no doubt about it, all right? But let's keep moving forward. Let's not be too discouraged. I'm going to take the a squared, those three terms, by the way. By the way, this thing here, you can rewrite that if you want, but I'm just going to make sure there's a symbol staying there. All right, so what do you get over here? Let's write this down. A squared x squared, a squared y squared, a squared z squared. That's done. Let's do the next thing, which is going to be b squared x squared. Let's see, b squared y squared. And then it's going to be c squared z squared. Wait a second, I'm sorry. I just lost track of what I was doing. Daydreaming again. Sorry about that. B squared z squared. All right, now we got to do the c squared. C squared x squared, c squared y squared, c squared z squared. All right? Let's take a look. And I'm starting to see things. I'm seeing a squared x squared, subtract both sides, they're gone. B squared y squared, subtract from both sides, they're gone. C squared z squared, subtract from both sides, they're gone. All right? A lot of things are gone. So what are you left off with? And I got to be careful here. So I'm gonna look around for I'm seeing this a squared y squared, and I'm gonna circle that guy right here. All right, and then I'm wondering. I'm seeing these guys over here, and I'm gonna say, minus 2. And I could do this in a variety of ways, but I'm going to do ABXY. And then I'm going to look for something else that might complete that square out. And I think I see it. And what's that going to be? That's going to be the b squared x squared. I'll write that down for you. So we took care of this guy here. All right, let's go for another one. Plus, let's do the, let's see, a squared z squared now. Minus, I am going to do 2ac xz. It's this guy here I'm doing. And let's look around for something that would complete that square. And that would be what? That would be a squared, let's see, x squared, right? Do I have one of those? Oh, a squared z squared. No, I'm sorry, not a. I need a c. So I need a c squared x squared. I see it right there. That's a perfect square. Let's keep moving. Plus, it's a lot of writing, but I'll show you where this is written down for you when I'm done with it. And what do we got now? First of all, I don't think I circled one of the guys I just used. So I use a squared y squared, b squared x squared, a squared z squared. Sorry about that, I forgot to circle it. We got some guys left over now. Let's write this down now. What do we got? We have b squared, z squared, and then we have a c squared, y squared. Let me circle those two. It's right over here, all right? And then I'm going to subtract this from both sides, which would be minus 2bc, y, z, and this would be this over here. All right? So then I want to point this out where it is. And it was work getting there. But I'm pretty comfortable that I know how they got there now. I'm going to erase all this business over here. I've done the expansion, and I'm pretty comfortable with that. So I want to make sure you know that what I'm comfortable with this is what I wrote down over here, which is the same thing as written over here. And then I wrote this down. That's the same thing that's written over here. And then I wrote this down. Whoops, I forgot to close the parentheses out though. Same thing that's written over here. All right, same thing. All right, and then I wrote this symbol down. Okay, what I'm going to do is erase down. I'm done with this. I'm pretty clear that where that came from. It took me time to get there, but I got there. The next thing I want to do is write down what the perfect squares are. And so, like I was saying before, I notice these perfect squares like immediately, that you get a perfect square here. That's ay minus bx quantity squared. The next one would be az minus cx quantity squared. And the third one would be this over here. All right? Now, I'm going to get my eraser out again. Erase this business here. And again, we're moving forward. And I'm on this line over here. All right, now, again, I want to remind you that really what this thing is saying over here, ay minus bx squared plus az minus cx squared plus bz minus cy quantity squared is actually greater than or equal to 0. All right, so I got to go over here and really think carefully about what they have over here. So it says, prove that if all letters represent unequal positive numbers. They represent unequal positive number. All right, so let's take a look. What do I know about these terms over here? Well, you know what? They could be 0. Even though they're unequal, ay could be exactly the same thing as bx. Could come in, even if they're unequal. All right? In other words, that a, b, x, and y are not the same. You can still get 0. The second term could still be 0. The third term could still be 0. It's possible. All right? However, I want to point out here that the more typical case is where ay minus bx is not 0, az minus cx is not 0, bz minus cy is not 0. So what about every single term? It's a positive number, except, of course, when it's 0. Would that always be greater than or equal to 0? Well, there is a case where it might be 0, and there's certainly a large number of cases where it's definitely going to be greater than 0. So yeah, this works out beautifully. All right? Okay, let me remind you again who I am. Name's Ron Bannon, and my email address is Bannon, B as in boy, the @ symbol, NNON.US. Thank you.